Alright, well, good morning, good afternoon, and good evening. We're going to go through section 6.3 again. We're going to have just one more example. We're going to say this is example D. It's going to be a little bit more challenging, I guess, because we have to make things just a little bit more challenging because on the test and on the quizzes. And in the next Math 141, it'll be a little bit more challenging as well. We'll have to remember how to factor, and probably it'll be a good idea to be able to factor and be comfortable using the trial and error method to see if something jumps out at us. So we're going to try and do this one more example. So here, if we're given that ax squared plus bx plus c, we've got a factor. We've got to find these factors, the underlined blue factors. And these factors multiplied together should give us that ax squared plus bx plus c. So that said, here's a couple steps that we'll need to remember. Probably you're very familiar with them already. We've gone through them a couple times. Step number one is making our life easy. Step two is write kind of the shell, the skeleton for our factorization. Step number three is determine the signs, and sometimes determining these signs might come later. And we'll find that in this example today. Step number four is the factor pairs of A go into the red boxes here. The factor pairs of A, here's our A, goes into the red boxes. And then step number five is the factors of C go into the green underlines. So we've got to factor C and put it into the green underlines. And then 6 is kind of play around with things, and then 7 is kind of check after we get something that we think is an answer. So that said, let's go to the next, let's go to some open space here. And we'll say this is our example here. We're going to say that this is, hang on a second. I've got 6x squared minus 5x minus 6. Alright, well there's our factorization, or sorry, there's our polynomial. And we need to, I guess the first thing we do is make our life easy. Number one, is it in descending order? I've got an x squared term, I've got an x term, and I've got an x to the 0th term. So 2, 1, 0, you put them in descending order based on the exponent. So it is in descending order already. Step number two is, or 1a I guess, factor out a greatest common factor. Is there a greatest common factor between this term, and that term? No, there's not. So we move on to the next step, factor out a -1 if a is negative. A is not negative, so already it's been given to us as kind of the easiest way to go. There's nothing we can do to make it easier to factor. So we start with writing our factorization skeleton, let's say. So there's an x, there's a blank going to go here, there's a blank going to go here, there's a blank and a blank. And now we have to go and say, well, here's my A is going to go factored here. We have to write our C, or I guess factor our C, and the C factorization would go here. And for this one, like I said, sometimes we assign the signs earlier, especially if this is a sum. If that C is a sum, in other words, if it's a plus C, then it's a lot easier because then you can decide that either they're both positive or they're both negative. And that's either both positive or both negative determined by this sign here, because they have to FOIL out, they have to be multiplied out. The inside terms and the outside terms have to multiply together and then add up to that term there. So that said, if the sign is negative, then one of these is negative, one is positive. And right now, we really don't know which one to put where. So we're going to kind of leave that sign alone for this example and say, let's move on to the factorization and maybe learn a trick here. So I'm going to put a couple of different options here, and I'm going to say if we factor our A term, make it green, I'm going to say, you know what, there's a couple different possibilities. My A term could be, and I'm going to just put them over here, 1 times 6, could be 2 times 3, could be 3 times 2, could be 6 times 1. So these pairs could go over right in here and right in there, or right in here, right here. Our red factors, our C factors, or our factors of C could be, and I'm going to ignore the sign for right now and just kind of plod forward. Could be 1 and 6, 2 and 3, could be 3 and 2, could be 6 and 1, because essentially we've got the same number. This is a negative, but we're going to not pay attention to the sign right now. So these are the possibilities for A. Could be 1 and 6, could be 2 and 3, could be 3 and 2, could be 6 and 1. And the red could be over here, could be essentially the same thing. 1 and 6, could be 2 and 3, 1 and 6, 2 and 3, 3 and 2, or 6 and 1. So we've got to now decide and maybe play around with them a little bit and see if we can maybe make our life easier with something like this. So let's take a look at some factorization. If we've got, for example, whoops, hang on a second, I'm going to make these green just to be consistent. If we've got, for example, we're going to put 1 here, and we're going to put 6 here. In other words, take our first choice. And the choices then for here, for our red terms, for our factorization of C, are over here. So I'm going to write down, let's see, well, this could be 1 and 6. It could be 2 and 3. It could be 3 and 2. It could be 6 and 1. But we're going to find that if we had something like this, so for example, if I look at this, 6x, and I had either a plus or minus, it doesn't really matter, but if I had 6x, let's go over here, put this in black, and I say, you know what, if I had 6x plus or minus 6, it really doesn't matter, but 6x plus 6 or 6x minus 6, then I could pull out a common factor and I could say, well, that would be 6 times x plus 1. And that would be able, this factor then would be able to be factored with the greatest common factor to put out here, just like this would be. 6x plus 6 could be written as 6 times x plus 1. But since we go to our original and we say, you know what, there's no greatest common factor that would be pulled out in front, so because there's no greatest common factor to factor out, then any of these factors down here also will not have a greatest common factor to pull out. So for that reason then, we can rule out, with my black rule, I can say, you know what, 6 and 6 are not going to make a pair. This could not be a factor, so I'm going to rule out 6 with my 6 in green. The same thing holds true for 3, because a common factor could be pulled out of 3 with 6x plus or minus 3. Same thing holds true for 6 and 2. And if these over here don't work, then the pairs just don't work. So we throw those out, and we say, all right, well, you know what? Maybe let's go to the next possibility. And right now, I'm going to leave that, and we're going to pursue whether this is a factor or not, or whether this is a correct factorization or not, for later. For right now, though, I'm going to go through the possibilities of everything that we've got. If we took 1 and 6 as our first option, then the next one down here would be, in terms of factoring A, would be 2 and 3. So if I've got 2 and 3 here, and I'm going to fill in my x's in black just to be consistent, then the next step would be to choose my A factors. And the A factors, the next, I guess all the factors of A could be written out just like the factors above. So all these factors for A down here could be written similarly up here. So I'm going to write down in red, hopefully. There we go. I'm going to write down 1 and 6, 2 and 3, 3 and 2, 6 and 1. And I'm trying to squeeze this in so I don't run out of room down here. And now we go through and say, well, is there something like this factor here, 3x plus or minus 6, could have a common factor, just like this one over here, this 6x minus 6, could have a common factor of 3. And that would come out here. But you know what? Up here in our original, it didn't have a greatest common factor to come out. So that means that I can throw that one away, because it's not going to work. It will not be a factor, because 3x plus 6 or 3x minus 6 would have a greatest common factor, and there's no greatest common factor. So we throw that one away, we throw that one away, and we throw the pairs away as well, because these pairs wouldn't work. And we can go over here and say that 2x plus or minus 6 would not work, because that would have a greatest common factor. And the others, this pair and this pair, might work, but you know what? Just let's be logical and then go through all of our possibilities. So down here we've got another possibility of x's, and to be honest with you, if you wanted to, you could go through here and say, you know what, is there anything that might work? But we're going to go through that thought process in just a second. So let's go through and just continue on our factorization. So we've done that one, we've done that one. Let's do the next one would be that one here, and I'll change to green so I can put my factors over here. This would be 3, and this would be 2. And then in red, my A factors would go over here. Again, it'd be 1 and 6, 2 and 3, 3 and 2, and I'm squishing just a little bit to try and fit everything in here so I don't get some gray area down here where my video is not going to play too well. And right here we're gonna kind of seal this off and say, now can I rule out any of these? I can rule out 2 and 6 because they would share a common factor. 2 and 2, they would share a common factor. Throw away the pairs because 6 and 1 wouldn't work. 2 and 3 wouldn't work because 2 doesn't work over here. 6 doesn't work over here. 3 over here, 3 and 6 don't work because they share a common factor, so throw away the pair as well. And now there's another possibility right here, and right here, and right here. So there's now only really just 3 possibilities that we've got. We've got one more factorization. I'm going to move it over here just so we have some room. Alright, my next factorization would be set up my shell or my skeleton. Next factorization would be that one there. So let's put our factors in green, I guess, of 6 and 1. Here's 6 and 1. And now the other possibilities in red for my C factors would be 1 and 6, 2 and 3, 3 and 2, and 6 and 1. And mentally you could probably go through this as well. But you know what? We're going to go through this and just logically show what we can do. Let's see. 6 and 2 share a common factor, so throw that one away and its pair. 6 and 3 common factor, likewise throw the pair away. 6 and 6 share a common factor, likewise throw the pair away. So again, now we're down to just another possibility. Alright, so now we've only got really 4 possibilities of factorizations that might be a solution. So let's go through and remember now that we've got to assign our signs, and then we've got to make sure that when we assign our signs that the multiplication of the outside terms and the inside terms adds up to -5. So let's just go through some of these possibilities and say, well, you know what, this is the only thing I've got, and I'll flesh it out down here. And I'll say this is 1x, and this is 6x, and all I'm doing is copying this down here and this down here. So now this possibility is a possibility, 1x. Now this could be a plus or a minus, and this could be a plus or a minus, but they have to be opposite. So if we say this is, it'd probably have to be, the majority is going to be, or I guess the larger magnitude multiplication have to be negative. So 6 times 6 is going to be the larger magnitude, because 6 times 6 is 36. 1 times 1 is, 1 times 1 is only 1. So if this were a possibility, we'd have to say that this would have to be negative, because negative 6 times 6 is going to give us negative 36. And we have to move back again towards the -5, but we're really only going to move back by a positive 1. So negative 36x plus 1x is not negative 5x. So we throw that one away. That is not a solution. Next possibility is right here, and I'll flesh it out here by saying 2x and 3x, and it's only because I'm just copying this down here, copying that down here. All right, so now I've got to remember again, because it's a negative sign, negative c, c is negative, then one of these signs is positive, one is negative, and again we've got to have a larger magnitude negative because our sum is going to be negative. So let's say that this would have to be negative right here, because negative 3 times 3 is 9. Is larger than 2 times 2 is 4, so we have to keep our sum negative. So that's why this 3 is going to be negative, has to be negative if it's going to be a solution. This has to be positive then, because they have to be opposites. And now let's take a look at what our inside and outside terms multiply together to. Negative 3 times 3 gives us negative 9x. 2 times 2 is plus 4x. Negative 9 plus 4 is actually negative 5. So you know what? There should be our solution right there. So let's assume that's our solution. So I'm going to put this in red and say this should be our solution. And let's move forward by foiling it out. And I'm going to go over here and make this my foil box, just because I've kind of run out of room. So let's foil what I've got right here. And I'm going to say, I've got a foil. So again, first outside, inside last. First terms, 2x times 3x gives me 6x squared. outside terms are 2x times 2 is plus 4x. Inside terms, minus 3 times positive 3x, minus 9x. Last terms, minus 3 times plus 2 is minus 6. Combine these like terms, and we get 6x squared minus 5x minus 6 is in fact what we started with, 6x squared minus 5x minus 6. So that FOIL, when we FOILed this out, we got that answer, which is what we originally started with, so that is our correct factorization. We've checked it out, and we can move on to the next question. All right, no homework from this section, just making sure that we know that we can do this, and this is the thought process we have to go through. We'll have a lot more process or a lot more practice in class. So see you in class, bring your questions.